Hey guys, how's it been going? This is JSer. In this video, I'm going to solve a 1-for-1 from BFE.dev. It's implement B2A. I think we seldom use this function, right? Unless we're handling some, I don't know, Bluetooth related stuff. It will, where we are going to transmit the binary data. Okay. Anyway, let's take a look at the description. B2A accepts a binary string and returns a base 64 encoded ASCII string from it. Characters in binary string are the ASCII character for each byte of the binary data. Okay, this is actually should be treated as binary data, but it is represented by converting 8 bits into ASCII code. Yeah. Okay, please read base 64. We can implement your own B2A. Let's see what it is. Okay. This is the example. This is the source. It's binary string. And we took 3 of them. And each will contains 8 bits. So 3 times 8, 24 bits. And 24 bits will be split into 4 groups, each containing 6 bits, like this, and it will be converted into a number, and which is the character code, and will convert it back to another character ASCII code, and then so MAN is transforming into TWFU. If there is only 2, and you see that if there's 2, there will be 16 bits, and we could convert 2 of them, right? 2 characters with the last 4 bits. We append 0 to it, and this will be transformed into E, and there will be 1 character missing out. So we add the equal equation mark. We would do the same for 1 character case, and just add enough padding with 2 equation mark and append these 4 zeros. Okay, so the idea is actually pretty straightforward according to this illustration table. We just take 3 characters out, and then transform them into bits, right? And then took every 6 of them and transform them back to a character. If that is not enough, we add the 0. If not enough, we would add the padding and form 4 characters and then push this 4 into the final result. Cool, let's do it. So first we hold the result array, and then I would say this is the buffer with the 4 characters, right? So we use a buffer, and then we would while how should we do it? Okay, this is the string. We took every 3 of them. Okay, so we could slice it and then pop it. We slice it and okay. Let the every how could I do this elegantly? We use a result, hold the final result. We use a buffer to cache the these results, and then we need to transform this into bits. We could just first wait a minute. Get the first 3 and set the string to the rest. right? Should I use okay. I'm wondering if I could just modify the string, or I should use an array to keep shifting. Okay, I would just modify the string. Okay. Yeah. Okay, so while string there is its characters left in the string, we get the first three. First three would be slice 0 3. Would be slice 3. Okay. This is the first three, and then we would convert it into binary. Binary would be first three. Okay, no, I just use a string concatenation let binary get bits for that character of string first three bits plus equals character get character code at 0 to a string and binary form. But should we actually we need to padding the zeros, right? So we padding start. What's the maximum length should be 8 and filled with 0. Great, now we have the bits, and then we extract the bits out. So we would get every 6 of them and push them into the buffer, right? Do it every time. And I think I could just do the buffer, create a buffer in the while loop. The problem. Yeah, and then transform, get the character at every 6 bits. So while this is while is not no, I would for add the pad the zeros if the 0 here if it is not enough. If not enough bits, so I would say the last here, right? So last octet, last octet would be no. I'll just keep doing the same for here. The same for this one as this one. Okay, while bits, the length would be, if there is bits, counts the first 6 would be bits slice 6, and the bits would be bits slice 6. If first 6, okay, we pad the first 6 with let. Okay, first here, pad end 6 with 0. Now this is const. Okay, now the character would be const character would be number parse int first 6 with 2 binary, right? And then we would string character from character code. Yeah, this is the character, and then we push the buffer, push character. So we get the buffer. Now, if buffer .length is not 4, it's smaller than 4, like this, right? We would add the padding with equation mark. So I would say buffer would push. Why we would push? Yeah, anyway, I use a push. Push is better. Push the buffer. Okay, no. The equation mark with repeat. Buff4 subtracted with buffer.length. Yeah, and then we get a buffer. This is the buffer, and the result would push buffer join empty string. The buffer is not pretty cool. Yeah, buffer is length. I would just use the final result here. Empty string. We append it. Plus equals buffer the join. And then we return the result. Great, so this is done. I'll add some comment here. Keep slicing by 3 characters, and then transform into the bits. Keep slicing 6 bits. Add the padding. Okay, let's try it. So we console log with BFE. See what it is. Dollar. What? Where is dollar? Haha. Okay. There's some bug here. Not right. Buffer. We slice the 3. Yeah. And then first 3. Okay, we log it. First 3. BFE. The bits. We get the character code here to string 2. And then pad start 8. 0. So we log the bits. Log bits. In a we're interview, there is no console log to see the results, so yeah. Okay, and then we get with the bits, well, it's not empty. We get the first 6 by slicing and pad. Yeah. Pad end 6. Yeah. Bits slice, and then from character code we parse int pushed character. If buffer console log the buffer dollar from character code. What's the oh yeah, no problem. Console log First to 6. We get this. And then we get this. From what's... Okay, we log it. 16. So string from character code is empty? I don't believe it. 16. Empty? Ah. Huh? It should be Q. Wait a minute. The Q 16. It should be Q. So it's not string Q 16 here. Ah. Oh, I see. The table actually in base 64 is not the it's not the ASCII code. I'm sorry. So it's not a string from character code, but there's a table. Okay, the base 64 table. Yeah, I made a mistake. I'm sorry. So I will write it down. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. And also the smaller case. Okay. I'll just write it down. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, X, Y, Z. And 0 to 9 plus and a slash. Plus slash. Okay, base 64. Actually, we should access by index, and so subtract, yeah. Just get direct access by push by this. BFE QKZF. Yeah, we get it. I made a mistake. Okay, submit. Great. This is interesting actually. It helped me understand what the basic 64 is. Actually, there are actually some other form like base 30 something. Anyway, it's just some similar process we could actually do without any problem, right? Okay, I post it. This is my solution. Go. Ooh, there are only a few people doing this. Well, this guy's solution looks much clearer than I do. I would say. Is my solution easy to understand? This is table, slicing 3 character, and oh, I'll remove the console here. Wow, what a shame. I'll remove the console lock here. Console lock here. There's console lock here. Console lock here. Go. Slicing. Keep slicing 6 bits. Add the padding. Result. Not that bad. Anyway, this is a fun problem. Hope you enjoyed this video. Don't forget to subscribe my channel. And see you next time. Bye bye.